Hello everyone. Today I am here to discuss about the basic terminology of the UV visible spectroscopy. After studying this lecture, you shall be able to know what is a spectroscopy, understand the basic principle of UV visible spectroscopy, know the concept of electronic transitions, and understand the applications of UV visible spectroscopy. What is spectroscopy? The branch of science concerned with the investigation and measurement of the spectra produced when the matter interacts with or emits electromagnetic radiations. Now discuss principles of the spectroscopy. The principle is based on the measurement of the spectrum of the sample containing atoms or molecules. Spectrum is a graph of intensity of absorbed or emitted radiations by the sample versus frequency or wavelength. Spectrometer is an instrument designed to measure the spectrum of a compound. Types of spectroscopy. Spectroscopy are of two types. One is absorption spectroscopy and another is emission spectroscopy. First, we discuss absorption spectroscopy, an analytical technique which concerns with the measurement of absorption electromagnetic radiation. An absorption spectrum is constituted by the frequencies of the light transmitted with the dark bands when the energy is absorbed by the electrons in the ground state to reach higher energy states. Examples of this spectroscopy are UV visible and IR spectroscopy. Emission spectroscopy. Emission spectroscopy is an analytical technique in which emission of a particle or radiation is dispersed according to some property of the emission and the amount of dispersion is measured. When the energy is absorbed by the electrons of an atom, electrons moves from lower energy levels to the higher energy levels. These excited electrons have to radiate energy to return ground state from the excited state, which is unstable. The emission spectrum is formed by the frequencies of these emitted light. Mass spectroscopy are the example of the emission spectroscopy. Now we discuss UV visible spectroscopy. UV visible spectroscopy are known as electronic spectroscopy. Why it is called electronic spectroscopy? Because it involves the transition of electrons within a molecule from lower to higher energy level or vice versa by absorption or emission of radiation falling in the UV visible range of electromagnetic spectrum. The approximate wavelength ranges of these regions are visible, having the wavelength 4000 angstrom to 8000 angstrom or 400 nanometer to 800 nanometer. Near UV 2000 angstrom to 4000 angstrom or 200 nanometer to 400 nanometer. For UV, having a wavelength 1500 angstrom to 2000 angstrom or 150 nanometer to 200 nanometer. Now we discuss Lambert's-Beer's law. Lambert's-Beer's law, when a beam of the monochromatic radiation is passed through the solution of an absorbing medium, the rate of the decrease of the intensity of the radiation with the thickness of the absorbing medium is directly proportional to the intensity of incident radiation as well as concentration of the solution. The mathematical expression of the Lambert's-Beer's law are log 10 I0 upon I is equals to ELC, where I0 and I are the incident and transmitted light. I is the path length of the absorbing solution in centimeter. C is the concentration in moles per liters. Locked in I0 upon I is the absorbance or optical density, and E is known as the molar extension coefficient and has unit of 1000 centimeter square per mole. Now we discuss types of electronic transitions. Electronic transitions are of four types. Number 1, sigma sigma star transition. Number 2, N sigma star transition. Number 3, pi pi star transition. And number 4, N pi star transition. All these transitions can be discussed one by one. So first we take sigma sigma star transition. Saturated hydrocarbon, that is alkane, having no non-bonding electrons are sigma sigma star transition. This type of transition can be easily shown by this graph. Sigma electron from orbital is excited to the corresponding anti-bonding orbital, that is sigma star. The energy required is large for this transition. For example, methane CH4 has CH bond only and can undergo sigma sigma star transition and show absorption maxima at 125 nanometer. Next, N sigma star transition. Saturated compound containing atoms with lone pair of electrons like oxygen, nitrogen, sulfur and halogens are capable of N sigma star transition. These transitions usually require less energy than sigma sigma star transition. The number of organic functional group with N sigma star peak in UV region is small, that is 150 to 250 nanometer. Next, we will discuss pi star transition. Unsaturated hydrocarbons having no non-bonding electrons are pi star transition. Pi electron is a bonding orbital is excited to the corresponding anti-bonding orbital pi star. Compounds containing multiple bonds like alkenes, alkynes, carbonyl, nitriles, aromatic compound, etc. undergo pi star transition. Example, alkenes generally absorb in the region of 170 to 205 nanometer. And last, N sigma star transition. An electron from the non-bonding orbital is promoted to the anti-bonding pi star transition orbital. Compounds containing double bond involving heteroatoms undergo such transition. N pi star transition are require minimum energy and show absorption at a longer wavelength around 300 nanometer. Example, aldehyde and ketones are in this category of N sigma star transition. What is chromophores and auxochromes? Chromophores, these are the color producing groups. Molecules or functional groups having pi orbitals are called as chromophores. Benzene, ketone, aldehyde are in the category of the chromophores. So what is auxochrome? Groups which are not chromophores themselves, but their presence can cause the increase in color intensity of compounds are known as auxochrome. Means it is a color enhancing group. OH group, Cl, NH2 are the examples of the auxochrome. Types of the band shift. Band shift are of four types: bathochromic shift, hypsochromic shift, hyperchromic shift, and hypochromic shift. Now we will discuss one by one. First we take bathochromic shift. Bathochromic shift, the shift of an absorption maximum, that is lambda max, towards the red end or the higher wavelength. That's why it is known as red shift. Next is hypsochromic shift. Shifting of the lambda max towards the blue end or the lower wavelength. That's why it is known as the blue shift. Next is hyperchromic shift, that is increase the intensity of the Emax, is known as hyperchromic shift. And last is hypochromic shift, that is decrease in intensity of absorption Emax, is known as hypochromic shift. At last, we are discussing the applications of the UV-VIS spectroscopy. UV-visible spectroscopy is highly used in the detection of the conjugation, in the detection of the functional group, in distinction between conjugated and non-conjugated compounds, in elucidation of the structure, and in detection of the geometric isomer. These are the image sources which are utilized in our PPT. And last, these are some practice questions which is based on our PPT. That is, define the term spectroscopy. Discuss the term chromophores or auxochromes with suitable examples. Define the types of electronic transitions and write a short notes on bathochromic and hypsochromic shift or hyperchromic and hyperchromic shift. These all are the references. Thank you.